In this video, we are going to discuss equal cofunction complements, and I just realized that this I in here should be an E. So go ahead and do that. Complements, like that, I think the I means like saying something nice. What we're wanting is a complement of something that finishes the other, like the complement to 10 of 7 is 3. 7 and 3 make 10. So what do we mean here then? That means we're talking about sine and cosine working together with these two types of angles. So what I'm going to do is we're going to figure out sine and cosine of those angles. So let's do sine of pi over 3 and cosine of pi over 3 first. Okay, pi over 3 is in quadrant 1, and it is my tall triangle. So I draw my tall triangle. I know that the big side is radical 3 over 2, and I know the small side is 1/2. So sine being my y is radical 3 over 2, and cosine being my x is 1/2. Okay, we're going to compare that now to sine of pi over 6 and cosine of pi over 6. Right, so pi over 6 is my short triangle. That looks like it's in the middle, so I'm going to do a little shallow, more shallow there. There we go. And that means that the long side, making it shorter, is radical 3 over 2, and the short side is 1/2. So sine is y, and cosine is x. So one thing you probably noticed, cosine of pi over 6 is equal to sine of pi over 3. And then sine of pi over 6 is equal to cosine of pi over 3. And we're wondering, coincidence, or is that a common thing? So first thing I want to point out, okay, pi over 3 is equal to 60 degrees, and pi over 6 is equal to 30 degrees. So that means when I add pi over 3 plus to pi over 6, I get pi over 2, which is 90 degrees. And I knew it was pi over 2 because I could add those two and see that it was 90. So when the angles are equal to 90, we get this weird relationship where the two angles that are in question, like here we have pi over 3 and pi over 6, the sines and cosines end up being the same because the angles add to 90. But why is that the case? Well, the case here is because if we look here, let's do an A, a B, and a C. Well, if they both add to 90 together, the two angles, I could put them in a triangle. If alpha and beta equal 90, I get this triangle here. I can make that because all three are going to add to 180 then. So I get a right triangle. So here's my right triangle, A, B, and C. And if I find sine of alpha, okay, sine of alpha, sine is opposite over hypotenuse, which is B over C, or Y over R. And if I do cosine of beta, the other angle, right, cosine is adjacent. So beta adjacent is B over C. Notice that they are the same, right? So as long as A and B add to 90, we're always going to get this because you can see that our ratios, like when I do beta, let me erase that circle here. When I do beta, I get B over C for the cosine, but when I do the other one for alpha and I do sine, I get B over C. It's the same because of the location of the sides, right? For alpha, opposite is the same as adjacent for beta. Hence the reason we get these things called cofunctions. So these are called cofunction identities. And the whole idea is that if I subtract 190, or my angle, like if I subtract 60 from 90, I get this other angle, which means that I get the relationship between sine and cosine. So this is what's happening here. Cosine of t is also equal to sine if I take my angle t and I subtract it from 90. But remember, 90 is pi over 2, right? So these are just in radians. If I wanted them in degrees, I could just put 90 degrees everywhere there's a pi over 2. So these are the relationships we get. Sine and cosine go together, right? That's kind of confusing because we're used to pairing the reciprocal functions. But those go together by the nature of the triangle, right? And then we also have that tangent and cotangent go together to do that. And it's the same idea because tangent is y over x, or opposite over adjacent, while cotangent is adjacent over opposite. Same thing with secant and cosecant. I do not really have these memorized. Throughout my math degree, I haven't touched them very much, if not at all, only when I'm teaching. So take that with a grain of salt. That probably not going to be something I'm too concerned with when it comes to testing. All right, let's do an example of this. All right, the example is cosecant of pi over 6 equals 2. And we're trying to find secant of pi over 3. Okay, well, I know that cosecant, let's write out a couple things here. Cosecant of t, I'm looking here now, is equal to secant of pi over 2 minus t. So if I follow this, cosecant, which is equal to 2, of pi over 6, actually I think we should do it the other way, maybe. Let's do it the other way. Forgive me. I realized I had it backwards. It's kind of weird because you're starting with one and going to the other. I'm going to start with secant of pi over 3 because that's what I'm trying to find, right? I want to get this equal to something. So secant of pi over 3, I'm not using the one I circled to begin with. I'm using this one now. Forgive me for that. Secant is cosecant of pi over 2 minus pi over 3. It's just following the formula up here. Well, the reason we knew this was going to work out is pi over 2 minus pi over 3 is pi over 6. Right? We know that pi over 6, because of what we did just above, pi over 6 and pi over 3 make 90. So if I subtract it from pi over 2, I'm going to get the other one. Well, I have the answer for that. The answer is 2. Pretty straightforward. You just have to use the definitions that are given.